All right, hello everybody. I hope you guys are having a great day. So today we are at Lakes Regional Park here in Fort Myers, and we're going to talk about some different stuff than our normal field trips. We're definitely going to talk about lakes here, but in Southwest Florida, a large lake like that we have here isn't really a natural feature, and so we'll talk about why this lake is here. And even though it is a man-made ecosystem, we're going to talk about some of the ecosystem services it still can provide for us, and some other features of lakes and ponds here in Florida. So I did mention that Lakes Regional Park is not a natural ecosystem. And if you're confused by that and you don't know the history of Lakes Regional Park, this area was actually dug out for fill for a lot of the surrounding roads and infrastructure here in Fort Myers. And then we were left with kind of a big hole in the ground. And so what we did with that is, was actually kind of a designed park around this big hole in the ground. And so what happened is the slopes of the banks of the hole were actually sloped. There was some native wetland vegetation was planted here. They introduced some native species of Florida fish, and from there a lot of birds came and used this area, so it is habitat for a lot of migratory birds and native birds to Southwest Florida. It serves as wetland detention for us, so when we have rainfall events, just like wetlands will hold water, this area will hold water as well, and so we'll talk about that a little bit more. And so even though it's not quite a natural ecosystem, it still provides many ecosystem services and ecosystem functions, just like a natural lake would. But again, here in Southwest Florida, a large lake like this is not really a natural feature. We typically don't have large lakes like this. We more have kind of our wetlands, our swamps, our marshes, and things like that. So let's take a second and talk about some of the ecosystem services that this ecosystem can provide for us. All right, so we've already mentioned similar services to wetlands, right? It will hold water, it will trap water, it will filter the water. And there's some control structures on Lakes Regional Park that we'll take a look at the later part of the field trip. So there's all those features, right? It's habitat for birds, it's habitat for fish. But one of the things that we often overlook as an ecosystem service is recreation. And so Lakes Regional Park is inside of a city, Fort Myers. It's one of the larger cities in Southwest Florida. And so having a place like this where people can go without having to leave the city is actually a very important part of, the principles of sustainability, and also just kind of makes the city a nicer place to live. So people have the ability to, get out and enjoy nature. Lakes Regional Park has running and walking trails. It has biking trails. It does have some short hiking trails going into some natural areas. And you could also rent canoes and kayaks and paddle boats and things like that here at Lakes Regional Park. There is a water park for the kids. There's playgrounds. And so having this natural feature in the middle of the city actually just really aids in getting people outdoors. And so that is an ecosystem service, which often gets overlooked when we talk about ecosystem services. Right? In addition to that, if we think about things like climate change, right, having green space is one of the things that can reduce the heat island effect of a city. Right? And if you're unfamiliar with what a heat island effect is, it's the idea that in most cities there's a lot more blacktop and concrete and less green space, and what that does is it absorbs more solar radiation and then it radiates that heat back out, and it increases the temperature of the area inside the city. One of the things to combat the heat island effect of cities is actually having more green space. So in areas such as Lakes Regional Park is one of the ways that we could actually control climate change by just simply having more green space. If we're continuing to talk about climate change, we could also think about carbon sequestration. And so again, that green space, having more plants, what are the plants continuously doing? They're pulling carbon out of the atmosphere. So if you notice, a lot of the parks and recreational areas will have things like these fountains in the water, and a lot of people think that the fountains just serve as kind of an aesthetic thing where it, you know, shoots water up in the air and it actually looks kind of nice. If you have ever been to the entrance of Florida Gulf Coast University and you pull in the main entrance, you'll notice even the body of water near the main entrance has a fountain in it. And I'm not talking about the fountain in front of Luckert. I'm talking about the fountain out near the main entrance of campus near Ben Hill Griffin Road. But the actual true purpose of these fountains, besides aesthetics, is it actually oxygenates the water. And so as this water goes up into the air, it picks up particles of oxygen. As it splashes into the water, it also picks up particles of oxygen, and it will put oxygen into the water. One thing that is important in an ecosystem such as this is having oxygen in the water. And if you actually look down, right, it is the summer months. It's actually pretty hot here, and it is also the rainy season, so we do have a lot of runoff. And so what's happening is there's probably a lot of algae actually growing in this water. And so having this excess oxygen into the water is actually important to prevent this water from actually being too stagnant. And if you're thinking to yourself, well, an algae is a plant, and plants take in carbon dioxide and they give off oxygen, shouldn't it be a good thing if there's a lot of algae in the water? And initially, yes, but then what happens is, right, a lot of this algae is very short-lived and it dies, and it becomes organic matter that sinks to the bottom and has to decay. And as things decay in the water, it consumes oxygen. And if you have too much decaying material too fast, consuming all that oxygen, it actually causes a drop in oxygen in the water. And then if that oxygen level in the water drops and it gets too low, things that depend on the oxygen, such as like the fish that live in the water, they will asphyxiate and they will die as well. And then you'll again have kind of a chain reaction of things dying and consuming oxygen, and not enough oxygen to help all that material to decay. And so the example I use when I talk about biological oxygen demand is if you have a piece of lasagna and you put it in a fancy piece of Tupperware that seals all the oxygen out, and you put it in the back of your fridge and you let it sit there for 2 weeks, and you take it out in 2 weeks and it still looks like lasagna. You probably don't want to eat it. But if you take that same piece of lasagna and you put it in your backyard in the summer in Florida, where it is exposed to the oxygen, and we in a magic world where we didn't have insects that would come and eat it, it would decompose a lot faster in your backyard because it's exposed to the oxygen in the air around it. And so having these fountains in the water is an important thing in Florida, especially in areas such as this where most of the water coming into the Lakes Regional Park is coming from runoff. It has excess pollutants, excess nutrients in it. And so having these fountains in here actually helps add oxygen to the water, and it helps break down all those excess nutrients in the water. So if you've been to Lakes Regional Park in the past, and not just in the last 2 years, but maybe a couple years before that, and you actually remember there being actually a lot of trees on these islands out here in the lake, and you don't see them anymore, and you're wondering what happened to those trees, and this is the first time you've been here in a couple of years. Most of the trees on the island were melaleuca trees, which were invasive here in Florida. and a lot of them were damaged after Hurricane Irma. And so the city of Fort Myers actually just took the opportunity, while most of them were damaged, to actually go out and remove a lot of those Melaleuca trees that were on these islands. So if you're wondering what happened to those trees, that's what happened to them. The other thing I want to take a quick look at while we're stopped here is this species we should be familiar with by now, which is lichen. And I'm going to talk about lichen in terms of a pioneer species, right? And so if you read the section in the textbook on ecological succession, right, we had two types of succession: primary succession and secondary succession. Secondary succession is where you have some ecological legacy left. So if you had a fire come through and it burns up a lot of the area, but many of the trees are still alive below the ground in their root structure, their seeds, not everything burned. Primary succession is where you have no ecological legacy left. Essentially, you put a parking lot over a natural area and there's no seeds, there's no life left. If you had an area where you had a volcanic eruption and that lava flow covered everything in solid rock, again, right, you're going to come back from primary succession. And so one of the very first species that will begin to grow if you've got primary succession is lichen. And so you've got this lichen here, and it's actually growing on this plastic material here that the boardwalk is made out of. And so the lichen is is pretty much growing in a pretty unlikely spot that you'd actually see a lot of plants growing. And so for primary succession to occur, you're going to have many generations of lichen where it's going to grow and it's going to die and it's going to grow and it's going to die. But as it grows and it dies, it adds a tiny layer of nutrients and organic material. And once that layer gets a little bit thicker, then you're going to have more stuff can actually start to grow. And I'm not super familiar with what things are, but it looks like there's a tiny plant growing there. I'm not sure if it's part of the lichen or it's actually just something that started to grow on this layer of organic material that the layer of lichen has left behind. So a couple of things while we're stopped here. These species that we're looking at here, these are the cattails, and these cattails are an obligate wetland species, which means they will only grow in a wetland. So when you're talking about wetland delineation, determining if an area is a wetland or not, if you see one of the species such as the cattail, right, again, which is an obligate wetland species, that's something that's only going to grow in a wetland. All right, so the other thing we have here, right, this is the pond apple. You can actually see a couple of these pond apples hanging on the tree right here, and it's just a neat species, so I just wanted to point it out. They don't taste very good if you try and eat them. And unrelated to the pond apple, we have the apple snail. So if you see these large shells like this, these are the apple snail shells. These are an invasive species here. Well, there's several species of apple snails, but these large ones like this are invasive here in Florida. Sometimes you'll see their eggs that actually, they'll be kind of, a few inches above the water line. I don't see any right here, but I'll point them out today if I find some. It almost kind of looks like pink bubble gum that somebody stuck on the base of a tree a few inches above the water line. Those are apple snail eggs. If you see anything that looks like that, but the eggs are actually a little bit larger and they're white color than the pink ones, those are actually the native apple snails. And so it's actually interesting that the eggs are a little bit larger, but the native apple snail is going to be a little bit smaller than this one. Okay, so while we're stopped here, let's talk about zones of the lake. And so, just like everything else, we could describe different regions of a lake by different characteristics. And so if we talk about just lake depth, right, along the shoreline, right, so right out here we have what's known as the littoral zone. And the littoral zone goes to a depth of about 5 feet. And in the littoral zone, you have emergent plants. So some of these plants that we see here in the water, they're rooted on the bottom and they're emerging out of the surface of the lake. Beyond the littoral zone, we have the limnetic zone. This is the open water zone. So the water is typically too deep for plants to grow on the bottom and emerge out of the surface. So the depth of the water in the littoral zone, typically deeper than 5 feet. All right, some other categories we could talk about with the lake is the benthic zone. And the benthic zone is the bottom of the lake. And when we talk about the benthic zone being the bottom of the lake, that doesn't just mean the bottom of the lake in the middle. It means the bottom of the lake from the shoreline all the way to the deepest parts of the lake. So the benthic zone is the bottom of the lake, regardless of what the depth is. Some other ways we could describe zones of the lake are how deep light penetrates into the lake. So depending on which textbook you're looking at, the depth that light penetrates down is sometimes called the euphotic zone or the photic zone. And this is the depth at which light will penetrate down into the lake. And so I often try and ask students, how deep can light penetrate into the water? And it's kind of a trick question because it depends. It depends on the turbidity of the water. It depends on the nutrient content of the water. It depends on the clarity of the water, right? Because the more stuff you have in this water, it's going to prevent light from going down to the bottom. And so can the photic zone penetrate all the way down to the benthic zone in the deepest parts of a lake? Yes, absolutely, if the water is clear enough. And so again, if we think about managing this lake and why we have the aerators in this lake adding the oxygen, right, that oxygen is going to help keep this lake clear. And then the more clear that this lake is, right, the deeper we could have plants growing on the bottom of the lake. And just like plants on the surface, right, they'll add, just like plants in the surface, they will add oxygen to the air. Plants in the water will add oxygen to the water. So a healthy ecosystem is going to have, plants growing in it, adding oxygen to the water, and then that oxygen is important for the species that survive in the lake. So quick review of our zones of the lake. We have the littoral zone along the shoreline, goes to a depth of about 5 feet, where we have the emergent plants. We have the limnetic zone, which is our open water zone. The benthic zone is the entire bottom of the lake from the shoreline all the way to the deepest parts of the lake. And we also have our euphotic or photic zone, depending on which book you're looking at, tells us how deep sunlight will penetrate into the water. So we've talked about Lakes Regional Park and how it is actually a created wetland, right, because it was originally dug out as fill for the surrounding areas. And as the surrounding areas were developed, right, a significant amount of impervious surface was built around this area in terms of roads and parking lots and houses and buildings, right, area where water can no longer percolate down into the ground or naturally flow along the surface as it would. And so much of that water is actually directed towards Lakes Regional Park and the surrounding areas. And as that water flows into this lake, right, it carries with it pollutants, it carries with it nutrients, and it carries with it just a sheer volume of water when we have a rainfall event. And so although Lakes Regional Park was a created wetland or a created park, it's also a managed park. And so what we're looking at here, this is actually the control structure for the water level in Lakes Regional Park. And you can see that, we've had a lot of rainfall in this last month, and the water's actually spilling over the control structure. And I don't know if you could figure it out by looking at the control structure. I don't know if you could figure it out by looking at the control structure here, but these gates can actually be closed, and we can increase the water level in Lakes Regional Park another 2 to 3 feet if we needed to. Right? Why would we want to do something like that? Right, so when the water comes into this park, we had mentioned it's got excess nutrients, it's got excess pollutants in it. And so if we were to close these gates down, and even naturally when the water comes into the lake, it doesn't immediately leave the lake. And so the pollutants and nutrients in this lake will often sink to the bottom of this lake. And when the water spills over the spillway, it's actually a little bit filtered. And so when the water leaves Lakes Regional Park, it's got less nutrients and less pollutants in it. And that's going to help the downstream ecosystems. The other thing that this control structure does for us, right, again, if we have a significant rainfall event, such as like a hurricane or just, you know, a big rainfall event, what it can do is we can actually drain the lake before that rainfall event comes, and we could use this lake as water storage, and so we're not inundating our downstream ecosystems with excess water. And so this water just kind of flows under this bridge, and it flows down and out of the park in this direction. Hello. A neat thing I'd like to point out as we're walking along here, I'm just going to take a side trail onto one of these little nature trails here, and notice the elevation change, right? We are gaining elevation about 4 or 5 feet above Lakes Regional Park as I walk along this trail. And when I'm here with students and I get to this point, I stop and I ask my students to look around. We increased in elevation about 4 or 5 feet over a very short distance, and our entire ecosystem changed. The other thing, you can't feel it in the video, but I would say it's about 4 or 5 degrees cooler here, right? We've got a lot more shade in this area, and we've got a lot more vegetation in this area. And again, so that vegetation is helping to moderate the climate in the area, and it's actually keeping it a little bit cooler right here. So just a neat little feature of a change in elevation can cause a total change in the ecosystem. So let's take a minute here and talk about a couple of final things for Lakes Regional Park and our lakes ecosystem. All right, so let's talk about nomenclature real quick. So what's the difference between a lake and a pond? All right, oftentimes you've probably used those terms interchangeably in your life. Essentially, a lake is a small or a large pond, or pond is a small lake. And so, you know, if you've thought that, you're mostly correct, but there's actually a specific definition, right? So a body of water that is larger than 10 acres is considered a lake. And if you have a body of water that's smaller than 10 acres, is considered a pond. All right, so the other thing that we're looking at here, right, we've got some nice chunks of exposed limestone, and right behind me here, you could actually see, you know, the evidence of, you know, fossilized shells and things that have been encased in this limestone as it was formed and as Florida had been formed over time. All right, so let's talk about lake turnover for a second. So if you remember when we talked about zones of the lake, right, most of the nutrients in the water will sink to the bottom. And most of the sunlight does not make its way to the bottom. Especially in this lake, you can see that the water's somewhat murky, so the sunlight is not making its way down to the bottom. Now, if you're a plant, what do you need? You need sunlight and you need nutrients. All right, so if you're growing on the bottom, you're not going to get sunlight, so that doesn't work. So you have to grow somewhere near the surface. But near the surface, you may not be getting enough nutrients. So how do we get nutrients back to the surface, right? And that's through the process of lake turnover. And so lake turnover can occur in two ways, right? One is seasonal temperature differences, right? And so if you have a body of water, you're going to have the warm water is going to be sitting on top of the colder water, right? So they're the different thermoclines, right? But then in the winter months, when the air gets cooler, it's going to cool the surface water. And if the water on the surface cools enough because of the cool air that it becomes cooler than the water on the bottom, then the water on the bottom of the lake is actually going to rise to the surface, and it's going to essentially flip. And when it flips like that, it brings nutrients back to the surface. The other way that we have lake turnover, and that's going to be more common in an area like this at Lakes Regional Park, is just prevailing wind. And so I've been here enough that I know that generally on this side of the lake, we typically have wind kind of blowing. It's blowing in this direction today, but it typically kind of comes from this direction. And so as that wind pushes water across the surface, right, it's pushing that surface water, and that surface water is not spilling over onto the edge of the lake here. Where does that surface water go when it hits this side, right? It actually goes down. And as it goes down, it goes along the bottom, and then it comes back up on the other side so we're getting kind of a loop, sort of like a conveyor belt in this lake. And as it's going along the bottom, what's it doing? It's picking up nutrients and it's bringing them back to the surface, where plants on the surface that have access to oxygen or access to sunlight can actually use those nutrients. All right, let's take a quick look at the map of Lakes Regional Park and what we did today. So I parked my car here in parking lot 2. This was the main sign where I was talking at the beginning of the video. This was the first stop where I talked about and gave some introduction to Lakes Regional Park. I walked out onto this little nub right here and I talked about ecosystem services of Lake Regional Park. We walked along right here, and this is where I talked about the fountains and biological oxygen demand. This is where I talked about the lichen. And I think this is where I talked about the zones of the lake right here. This was the control structure right here, where I talked about how we control the lake's water levels. This is where we hiked up and we saw the pine trees, where they had the elevation change and the ecosystem change. And right over here, this is where we talked about the difference between a pond and a lake and lake turnover. And then following this trail, I'm just gonna walk back this way, back to my car. But if we actually look at the entire size of Lakes Regional Park, right, they've got more trails over here. We've got another trail that goes in this direction. We've got a trail that goes around. So it's actually a much larger park than we're talking about today. But again, when we talk about ecosystem services, we can't forget recreation. And so this actually provides a nice recreational area inside of a city. So I hope you learned something on our Lakes Regional Park field trip, and thanks for following along with us today.